Hello, good morning. Today I'd like to talk to you about when you physically turn on the power switch on the router, what happens. We're going to take that step by step, explaining what it takes for the router to boot up and what needs to be loaded for the operating for the router to be operational. So this way it'll be very easy to troubleshoot if anything goes wrong. All right, so let's start by when you first turn your router on. First thing that happens, just like the PC, a program called the post, the power on self, which is will start several diagnostic programs that's going to test the internal hardware of the router to make sure the CPU, the memory, everything is in where they're supposed to be. And if you take a look at the router LED light on the front, it'll be a green light. The system light, it'll be blinking light. That means the post is still running. Once it turns solid green, that means everything is successful. If it turns an amber color, that means there's a hardware problem that you have and you have to attend to. And nothing will happen after that, so nothing gets loaded. So let's assume that the post, which is from a ROM chip, a read-only memory chip on the motherboard, loads up and starts the several diagnostic programs. Once those several diagnostic programs are successful, then another program called Bootstrap, which also located on a ROM chip on the motherboard, loads the operating system. Now the boot sequence for the operating system, just like your boot sequence on your computer, your computer looks, for example, at the DVD, then maybe the flash drive, and maybe finally the hard drive to load the operating system. Bootstrap on the router goes and looks for an operating system on the flash memory chip that's on the motherboard. If it's not there or if it's corrupted, it will go to a TFTP server if it's been configured. Remember, I think we did that a while back. If we didn't do it, we'll do it again. How we can back up an operating system on a TFTP server, but it has to be connected, it has to be configured. So if it's not there, then it will go to a ROM chip where there is only some 4 iOS files that are loaded on the motherboard, that are loaded on that chip, on that flash chip. iOS stands for the Internet Working Operating System. If you see this prompt, ROM mod, that means the operating system was not loaded correctly from the flash. And you need to attend to it because you only have some, basic commands. This is equivalent to when you turn your computer on, you did not load the full operating system. You just loaded some basic files in safe mode, even less than safe mode. If you remember in the old DOS, it was just like a few files that allowed you to do a few commands. So here's just, this is in a read-only memory chip. This is not the full operating system. You won't be able to do much. This is really a place where you can reload an operating system that allows you to do that and things like that. We will be able to do something with this maybe next semester when we back up and restore an operating system with configuration file. We'll be able to do this online. Now, assuming that Bootstrap finds the operating system, Bootstrap finds the operating system in the flash. It loads it up and it goes to memory. Now, once the iOS is loaded into the RAM in memory, then it goes and looks for a configuration file. Now, before it goes and looks for a configuration file, he also goes into a configuration register. He looks at the configuration register. There's a number in there, and the number is usually 0x2102. Now, 0x means inside that configuration register, that means these numbers 2, 1, if a number is preceded by the number 0 and the letter x, and all the numbers after it are in hexadecimal. That's what that means when you see that in around. We're just looking at the last two digits. The last two digits, if it's 02, it indicates that iOS should look for a configuration file in a non-volatile RAM. If it's not there, it's going to look at a TFTP server. It's not there, you'll go into the setup mode. The setup mode means that, let me explain. The iOS, when it gets loaded, the operating system on let's say a computer, that's all it needs, because it just runs applications and takes commands from you and does whatever you need to do. But for a router, when the operating system is loaded, it needs a configuration file. A configuration file means that we have to tell the router what are the interfaces, IP addresses, for example. We want the router, for example, to act as a DHCP server. We want the router to act as a DNS server or a NAT or create a VPN. So when we want to tell the router to do something for us, we have to create a configuration file and give it to the operating system, and then the operating system is going to read the configuration file and act upon what we have told it. So the operating system will not be able to operate the router if you have not created a configuration file to it for it. Okay, so when we create a configuration file, when we type these commands, they go immediately into the RAM, and the iOS reads it and is processed by the CPU. But if you don't save that configuration file, as we all know, anything that goes in the RAM gets erased if you turn off or reload the router. But we'll talk about that. So you have to save it in a non-volatile RAM, that configuration file. You save it in the non-volatile RAM, so every time you reboot, the iOS will go to it looks at the configuration register, he sees the number 02 at the end of the configuration register, then he's told to go to the NVRAM and look for a configuration file and load it up. Okay? If it sees a 42, it will ignore all of this, it will ignore steps A and B and go to the setup mode. If somehow you put a 42 in the configuration register. We will be able, for example, let's say you bought a router off of eBay, and it has a password in the configuration file, and the configuration file is saved in the NVRAM. Every time you load up the operating system, you are prompted for a password because it loads the operating system from here. So what you can do is you can go in, change the configuration register to 42, tell the operating system to skip and go into the setup mode, and you'll be able to, that's how we really restore a password. Don't load the configuration file from the NVRAM, and we'll be able to fix it that way. But we'll talk about that, how to restore a password on a different video, and most likely we'll do that next semester. Okay? Now, if you don't get that, if there's no configuration file, you go into the setup mode, and you'll see that statement. I'll show you that I'll do a little bit of configuration for you when we get on the router itself. But those are the 4 steps when you turn off the router. Turn it off and turn it back on. All right? I just want to remind you, there are 4 different RAMs that you should be familiar with. The random access memory. This is where the running operating system is, for example, here. Let me show you. And random access memory is made up of capacitors. And capacitors always gets discharged unless you keep the power on. That's why they need to be refreshed. So every time the CPU, the central processor unit, the brain of the router or the PC, always grabs information from the RAM, brings it in, and processes it. So, because you can have so much RAM in there. So the stuff that when we load the operating system, the operating system is in codes. It has to be decompressed, quote unquote, made into an opcode or a machine code so that the CPU can understand. So that's why we bring it into memory. And then the CPU will fetch the information from the RAM, bring it to the CPU, and process it. Everything has to go into RAM. The more RAM you have, the more files or applications that you can run, right, in terms of the PC. Now, the only problem with RAM is you got to keep power on, because otherwise, if you turn off the power, you'll lose all the data that's in here. So when you create a configuration file, that configuration file goes immediately into RAM, and because the iOS got loaded from the ROM chip, from the flash chip, because the operating system is here. So when you turn your router on, the first thing that's going to happen is the iOS goes from here into the RAM. And then the operating system will go in and grab a configuration file, bring it into the RAM, and starts giving stuff to the CPU for processing. And then the operating system then will does whatever it does. For example, run a routing protocol for you, or create a DHCP or whatever. Host and Bootstrap, they come from a read-only memory chip. A read-only memory chip is a hardwired program on the chip. You can't make any changes to that program. And the good thing about a program on a ROM is that if you turn off the power, because it's hardwired, it will always be there. If you turn it back on, the program comes back up. So it never gets erased with a ROM chip. With a non-volatile RAM, it's really similar to the same, pretty much the same as RAM, but there is a rechargeable battery that's next to it, so that when you turn off the power, it keeps the information stored in the RAM. You don't lose it. But if you unplug the router or the PC, for example, for a long time, that rechargeable battery eventually will die out, and you'll lose all the information in the RAM, like the BIOS chip on the PC. The flash memory chips are the best. Flash memory chips acts like a ROM, but you can modify the information in there, just like those flash drives that we have. This is where the core operating system will always reside. This is where the NVRAM is where the startup configuration. That's the one after you do the configuration, you save it in the NVRAM. We really don't do much here. This is where, for the ROM, this is where the post, the bootstrap, and if there is no operating system in the flash, this is where the core iOS files are going to be, right? That's where they're going to be located. All right, I just wanted to make sure this is all on the motherboard on the CPU. If you have a switch, the flash, you can actually see it from the outside. You can pop that flash chip out. Okay. All right, so that's basically what happens when you cold boot a router. Let's take a look at the actual configuration on a router. So here's a typical connection. I want to do some configuration on the router. So what I'm going to do is I'm going to do some basic configuration on it. So let me actually go through the console cable. So let me connect through my RS-232, the 910 serial port. I'll go to the router and connect to the console. Okay. And then I'll go through desktop, and I'll go through my terminal. This is equivalent to PuTTY. And now I have access. Now, look, when you see this continue with the configuration, let me go into the router, and I'll go and turn it off. So what I'm going to do is right here, turn off the router. So when you turn off the router, and then I'm going to turn it back on. And let's take a look. You see that the router is booting. So what happened right here is the post ran. Unfortunately, we can't see this because it's really just a virtual machine. It's not a real router. So what happened is the operating system was loaded from flash, and then the operating system could not see a configuration file in the NVRAM. So this is really the setup mode at the end. And there's of course no TFTP setup. So it's asking you, do you want to continue with the configuration? And you say no, because the router did not see a configuration file. It says we have to create one for you. So why then am I typing no? Well, I'm typing no because if you type yes, it's going to start asking you questions on that, every single little detail about configuration. And you're going to have to say no, no, this, no, that. I say no because I want to create my own configuration file as quickly as a small one. So if I want to do, let's say, a routing protocol or a DHCP server, I'll say no, and I'll just create a configuration file and have the router act as the DHCP server, for example. All right, so you always say no because you are going to create your own little configuration file and you know what to do. When you type no, you go into the user mode. In the user mode, it's only used for basic configuration. So when you do the question mark in the user mode, these are the only commands that enable you to do, um, you'll be able to use. Not much. Most of them is really just to show some basic configurations and things like that. So if you want to be able to do anything, you go into the privilege mode, a mode above it. So there's four modes actually that I to go into. So you type the word enable and you hit enter. So enable turns on the privilege commands. If you hit enter, now you're in a different mode. And how do you know you are in the privilege mode? Because you see that pound sign, that number sign next to the prompt, or prompt the router. So you are in the privilege mode. If you want to do now if you do a question mark right here, you see a lot more commands. And the word command on the bottom, the word more on the bottom, indicates that you have more commands. So you hit the space bar. Now, if you want to create a configuration file, then you got to go to the global configuration mode, another mode. So that's mode number 3. So you type configure space terminal. Okay? We're not doing any shortcuts yet. We'll talk about the shortcuts in a minute. So now that's the global configuration mode. Now, if you want to do a specific, let's say you want to go to this interface and create a configuration, give it an IP address. You type interface and you write fast Ethernet 0/0. Right? You have to type a lot of stuff. And now you are a specific global mode. Now, so the 4 modes that you can be in on the router is the user, privilege, global configuration, and specific global configuration. How do you know you're in a specific global configuration? You'll see config dash. In this case, it's IF for interface. It could be VLAN if you are in the VLAN, for example. If you type exit, you'll go back to the configuration mode, to the global configuration mode. If you type exit again, you'll be back into the privilege mode. If you type exit again, you'll back to the user mode. Okay? Now, here's something nice about this operating system. If you don't remember what the commands are, you can always use the online help, the question mark. So put the question mark and a list of all the commands that are available to you. If the commands are not here, then that means you cannot do it. All right? So if I just type the letter E instead of typing enable to go into the privilege mode and hit enter, the router is going to say this is an ambiguous command. Why? Because it looked at all the commands that starts with the letter E, and it saw 2 of them, enable and exit. It didn't know what to do. It didn't know which one it's going to execute for you. So that's why it was a little bit confused. It's not sure which one you want to do. If I type EN instead, I go into the privilege mode. Now, because the only command that starts with the letters EN is the word enable. So now we can actually use EN instead of enable because we know EN is the only one that allows us to get into the privilege mode. So you can now use shortcuts. So you can actually use SH instead of show, right? And you can use INT instead of interface, ADD instead of add, FA instead of fast Ethernet, config instead of configure, the letter T when you're at config T instead of the word terminal. By the way, you could type here, let me exit out of here, go back. You could type EN, if you hit the tab key, it writes out the command for you. You want to do it that way. So you type enable, let's go into the config T, alright. So let me do a question mark. It's going to give me all the commands. So let's say I want to change the system clock. And here, it starts with the letter C. Well, let's say you're right here and you don't know. You write the letter C, and right next to the letter C, you put a question mark. It's going to tell me, listen, you got the commands CDP, class, clock, configure, register, or crypto. Which one do you want? So I want clock. So I'm going to say CL and O, and hit the tab key. It gives me the word quad. Now put a space. Then you say, I don't know what to type after that. So you put a question mark. It's this type of time zone or configured. So you write time zone with the space bar. You don't know what to write with a space bar. Give it a name. So time zone, let's say Eastern. Put a space. Is there anything else I want to do? What hours? So let's say 05. Put a space. Question mark. Minutes. Let's say 00. Question. Oops. Space. Question mark. And that's it. So now you can change the time zone in Eastern time. Right? You can do host name. So by the way, so from now on you should know that you type the letters. If you put the question mark right next to the letter, it will complete the command for you. If you put a space after the command and you put a question mark, then that question mark is going to give you all the parameters that come out with the, like for example, when I typed in the word C, it gave me the C question mark next to the letter C, it gave me all the commands that starts with the letter C. Right? For example, if I type the word router, which starts the routing operating system, and I put a question mark, it gives me these four choices, right? So these are parameters that I can do with the router. So if you want to start EIGRE or SPF or RIP, you just write, for example, R. You don't even have to write anything after that. If I write R and just hit enter, it's going to do router RIP. It's going to start the routing quote unquote RIP. You don't have to write the whole word out, just the letter R, right? And you see we are in a specific global configuration mode. Alright, so let me exit here. Let me do the host name. Change the host name of the router. So I'm going to write host name and capital R1. Let's say, changing the name of it. Let me type no IP domain lookup. This will disable the DNS lookup. So in case you typed in anything by a mistake or not, it's not going to go and look it up, that mistake in the DNS server, and so we're going to tell the router just to ignore that. A host name, you need a host name for a device so that you know exactly where that router is located when you are telnetting or remote accessing to it. Let me go to this interface. Let me go to the interface itself, the fast Ethernet interface. Let's talk about that. INT for interface, FA for fast Ethernet 0/0, and give it the IP address 192.168.10.1, let's say, space 5.5.5.0, that's the mask, and we type no shut. It turns on. Okay. You can actually give a description to this interface. You write the word DES with the tab key. Like this is LAN 1, for example. Right? And what I want to do next now is I want to type exit. Now all this configuration that I just did, let me type exit again. You can take a look at it by typing show sh run. Show me the running configuration file, the one that I've just created that is sitting in the RAM, in the router. So when I type show run, there it is. There are some basic commands that are already in the running configuration file, but this one I included a host name, right? I put space bar. The no domain lookup is in there. I put that in there. And the configuration file of the interface, right? Now, if you type show starts, which is start up, the one that's in DRAM, it says there's nothing in there. So if I ever reboot this router, I'm going to lose this configuration that I just did. So what I want to do is I want to say copy, run, the running configuration that I just did to the startup configuration. So what I'm doing is I want to copy going back in here, I want to copy the configuration file that I put in here. I want to store it in the NVRAM. So this is where the running configuration, I want to put it in the NVRAM. So next time I reboot, it always gets loaded back up, right? So that's the whole idea behind this. And I hit enter. And it says this is what you want to call it. When you save it in the NVRAM, you have to accepting whatever's in the brackets. So now if you start show start, it has the copy of the configuration file, and now you can actually reboot the router, and you'll be fine. So I can actually go and go to the router. I'm going to turn it off and turn it back on, and when I go to the router itself, you can actually access the router from here without as you all know, without having the console. In fact, let me get rid of the console port right now, and it's easier to get into the router here. So now I have the configuration that I want. That came from the NVRAM. Okay, and if you type en, you can type show run. Well, let me type show version. Show version is always helpful because it tells you the name of the operating system that's in the flash right here, right? First tells you exactly the operating system is made for the 2800 router. This is an advice, advanced services. Second part tells you what features it has. This is the advanced IP services. It allows you to create VPN and an IDS's firewall. So it's a pretty good operating system. It has all these features. And this is a binary one. This is version 12.4 to 15 P1 version. We'll talk more about this exactly in detail, these features and the different features of different operating systems in 206 graphs. If you go all the way to the bottom, you see it does what the configuration register is set up for. So it's set up to always go to the NVRAM to grab the configuration file. Right? We can change this, and I will show you how to change that in a different class. Also, down at the bottom, it tells you the memory and how much availability of the memory that you have. So the show version command is very helpful. So if you're on the phone with help desk and they're asking you what type of operating system you have, you type show version, and you can read it out to tell you how much memory you have. You can type show flash, for example, to tell you. You can find out what's in the flash, the operating system, right? All right. So hopefully that explains everything that you need to know about how the router boots up. So until next time, talk to you later.